Hello students, today we are dealing with the class 10 physical science topic of gas laws. This chapter deals with the properties of gases, especially the volume of a gas, as how volume of a gas depends on various other parameters of gas such as temperature of the gas or the pressure of the gas and so many other factors that controls the properties of gases. Regarding the behavior of gas, one of the earliest proposition or the law you can say is nothing but the kinetic theory of gases. This theory talks about the behavior of gas such as volume of a gas, why gases occupy volume and why do they occupy large volume, and how gases exerts pressure, all that, and how temperature controls the molecular behavior of gases is all explained in this theory called kinetic theory of gases. There are many points and postulates in this theory. So it begins like this. First of all, it tells us that gases are made up of many different smaller, very tiny entities called molecules. All gases are made up of very small particles called molecules. We all know that every substance, not only gases, even liquids and solids are also made up of tiny particles such as atoms and molecules. So here it says that all the gases are made up of very small particles called molecules. You see, it talks about molecule, but what about atoms? Don't you think that gases also have atoms in them? Actually, gases are made up of atoms, but those atoms, they don't stay free. The atoms of gases, they combine, they join with one another. Most of the time, two atoms of gases joins to form an entity called molecule. So all gases are made up of very small particles called molecules. Let's say, let me draw a molecule of oxygen. This is a molecule of oxygen which is formed by joining two atoms of oxygen. This is one atom of oxygen. That's another atom of oxygen. So when two atoms join, that particle form is called molecule. Even though the molecule of gases are made up of two or more than two atoms joined together, but because atoms are small, so only two or few atoms when they join, the molecule formed is also not so big. So molecule will be very small, so small that we won't be able to see them with our naked eyes, not even with the microscope. So they are extremely small. So all gases are made up of very small particles called molecules. In the second postulate, kinetic theory of gases talks about these molecules moving randomly. In gases, molecules are not fixed. They are not placed in one position. They are all the time randomly moving here and there. Their motion is chaotic. They don't move in one particular direction. One molecule moves this side, another moves another direction, and they keep on moving ceaselessly. Never-ending motion is there in gas molecules. So gas molecules constantly or ceaselessly moves in all possible direction and with all possible velocities. They not only move in different directions, but their velocities are also different. Some gas molecules may be moving slowly, sluggishly, whereas some other gas molecules moving with a tremendously high velocity. So they have different velocity and they are moving in different direction, and their motion is constant, they never cease to move, they constantly move, so that means they never stop. And you know, when gas molecules move this way in such a random fashion in all possible direction, what happens? They quite often hit one another, they bang on one another because of the random motion, and they not only hit or collide with one another, but they also happen to collide on the walls of the container. So if you have a container like this, let's say a gas jar or a chamber where the gas molecules are kept, so these molecules, because they're moving randomly here and there, what do? They sometimes go and strike another molecule, and sometimes they also hit the wall of the container in which the gas molecules are kept. So they constantly move and bang on the walls. So that way, by striking the surface of the wall, they are exerting some force on the surface. So the third postulate talks about their collision, when they hit each other and when they strike the surface of the wall of the container, that phenomena is called collision, and that collision is, elastic collision. Elastic means, in our world, when two objects collide with one another, when they hit each other, they happen to lose some amount of their energy. That energy gets converted to heat, or sometimes get converted to sound, like when you collide two objects like this. Let's say marker collides on the board, you see it produces sound. So some of the energy gets dissipated in the form of sound, some gets dissipated in bringing wear and tear to this, because when they collide they happen to cause some kind of wear and tear or cracks on each other, and because of that some energy gets always lost in the form of heat, sound, or sometimes even the flashes of light. But in molecular world, that collision is elastic collision, which means when molecules hit one another, they don't lose any energy. And when they also happen to bang on the walls of the container, there also they never lose energy. And such a collision, where after colliding, if they don't lose any energy, they retain the same amount of energy which they had earlier before collision, then that kind of collision is called elastic collision. That means the collision in our world is inelastic, because when they collide, in larger entities, when they collide, they always lose energy, and that's why it is inelastic. But molecular collision is elastic. So molecules of gases constantly collide with each other, and also on the walls of the container. So they also collide on the walls of the container. Okay, so I want you to pause the video and copy all these postulates, because you can get some questions based on this. They may either ask you to write some of these postulates, or maybe they'll ask some questions based on the points written here. So I want you to copy this. I'll be enlisting more points. There are several other points in this theory called kinetic theory of gases. Okay. Next, not with this. This is going to be better. Yeah. So after the collision, what happens? You already know that they don't lose energy. Their collision is elastic. So the fourth postulate says that collision of gas molecules are collisions, let's say, collisions of gas molecules are perfectly elastic. It means they never lose any energy during their collision. Now, fifth point says, now this is very important. Why? Because it explains why gases exert pressure. Gases exert pressure because I think you know what is pressure. You know, over here on the surface of this board also, whatever gas molecules are there in this room, they are constantly banging on these surfaces. Here, everywhere gas molecules are hitting now. We can't see that happening, but they are constantly striking here. And when the gas molecule strikes here, what do? They exert force. So this board has a large area. Okay, its area could be, let's say, if it's centimeter, some 1000 centimeter square. If it's meter, some meter square. So its area is not 1. Okay, let us assume that the area of this board is around let's say 5000 centimeter square, suppose. How do you calculate the area of this board? By multiplying its length in centimeter with the breadth. Length into breadth gives you the area. So let us assume that the area of this board is 5000 centimeters square. So when gas molecules exert force on this surface of the board, you know, the total force exerted on this board is called the thrust. That is the total force, whatever force the gas molecule exerts by hitting the entire surface of this board is the thrust. Okay. So let us assume that the force, total force here on this is around 20,000 dyne, let's say. I think you're familiar with this unit of force. Force has units such as dyne and Newton. Dyne is a Celsius unit of force, whereas Newton is SI unit. So I'm using Celsius unit of force, dyne. So on the entire surface of this board, by striking, gas molecules are exerting what force now? 20,000. Okay. Is this force the pressure exerted by the gas molecules on this board? No. Because pressure is not the force exerted on the entire area. Pressure is the force exerted only on the unit area. Unit means only 1. Unit means, let's say, if it is centimeter square, only on 1 centimeter square. So you can take, this is not 1 centimeter square, it is much larger. But because if I really draw 1 centimeter square, it's going to be very small, something like this. So you won't be able to see. So I've just enlarged that area of 1 centimeter square. So this could be 1 centimeter square, 1 centimeter by 1 centimeter. So this is unit area. Whatever force is exerted only on this area, on one area, that force exerted on one area is called pressure, not the force exerted on the entire large area. So on the entire board, the total force is this much. Okay. So on 5000 centimeter square area of the board, whatever force the gas molecules are exerting by striking them on the surface is that much. Is this force the pressure exerted by the gas? No, because this is the force exerted not on one area but on 5000 centimeter square. So if on 5000 centimeter square, if this much of force is exerted by gas molecules by striking the surface, then what is the force exerted on unit area, that is one area? So on 5000 centimeter square, you've got this much. On 1 centimeter square, how much will be? What are you supposed to do? You're supposed to divide that force, that is 20,000 dyne, by this one. That's how unitary methods are executed, you know. On this area, that is the amount of force exerted. Then what would be the force exerted on 1 centimeter square? So you just divide it. So it will be 5000 centimeter square. So now this is now when you divide, it goes something like this. So 4 is left. So 4 dyne of force on each centimeter square, so per centimeter square. So this is the amount of force that is exerted on the unit area. And whatever force is exerted on one area, unit area, not on the larger or entire area, that amount of force is called pressure. See how we got pressure here? We got pressure by dividing the force by area. This is the area on which the force was exerted. So that's the total force exerted, total thrust on this area. So when the total force is divided by the total area, what do we get? We get the force exerted on one area, and force exerted on unit area or one area is called pressure. So how do we calculate pressure? Therefore pressure is calculated by dividing the total force by the area on which the force is exerted, because when we divide the total force by area, we get the force exerted on only one area, that is known as pressure. Okay, that's why the formula pressure or pressure exerted by gases or liquid is always like this, force by area. So you've got to know this, what is pressure first of all, and how do we calculate pressure. Now, this theory called kinetic theory of gases now explains why gases exerts pressure. Gases exerts pressure because gas molecules, they go and hit on the surface of the container. They are constantly bombarding on the surface of the container. That way they exert force on that, and that force, when you calculate on the unit area, on one area, how do you calculate? You first find out how much of force all these gas molecules are exerting on the entire area of this chamber. That force divided by whatever area this has, you have to divide that with area, and that gives the pressure. So pressure exerted by the gas molecule is all because of this gas molecules collision on the surface of the container. Because gas molecules are colliding, they are banging on the surface of the container, they are exerting force, and that force exerted by the gas molecules on the wall, when you divide by the area, you get the pressure. Okay, so pressure exerted by the gas molecules is the force exerted by the gas molecules on the unit area of the surface of the container. Okay, so this theory beautifully explains why gases exerts pressure, because gases, their molecules go and hit on the surface of the container. That way they exert force, and that whatever force they exert on only in one area, that is known as the pressure exerted by gas molecules. Okay, so that's the fifth postulate of kinetic theory of gases. And the sixth one, gas molecules are so tiny that they themselves do not occupy any volume. It says that gas molecules are extremely small. They're so small that they don't occupy any space. Then how do gases occupy so much of volume? You know that compared to the two other states of matter, like solid state and liquid state, gases always occupy large volume. But it says that gas molecules themselves, they don't occupy any volume. Then how gases occupy such huge volume when their molecules themselves occupy no volume because they are extremely small? The volume occupied by the gas is not because of the volume occupied by the gas molecules themselves, because the gas molecules are so small that they don't occupy any volume themselves. So why do gases occupy so much of volume? Is because gas molecules are widely separated. You know, in solids, molecules are tightly packed. There's no gap between them. In liquids, they are slightly separated, so they can move around. So there's gap between molecules in liquid. But in gases, they are widely separated. Gas molecules are far from one another. Okay, so the huge volume occupied by the gas is all because of the large space that lies between the molecule. Okay, molecules themselves are so small that they don't occupy any space. But gases occupy huge space because of huge gap between them. So much of space is there in between molecules, and that's why they occupy large volume. So gas molecules are so tiny that they themselves do not occupy any volume. So the volume occupied by gases is due to Hughes intermolecular, oh come on, Hughes intermolecular space. Because gas molecules have a lot of space in them, that's called intermolecular space, because that's a space between different molecules. And because of Hughes intermolecular space, gas occupy a lot of volume, but volume occupied by the gas is not because of the molecules themselves, because molecules are so tiny that molecules do not occupy any space. So that means, imagine you have 20 liters of gas, that 20 liters is all empty space. It's not the space that molecules occupy, because this law assumes that gas themselves do not occupy, gas molecules themselves are so small that they don't occupy any volume, but yet you have a gas occupying 20 liters. So that 20 liters is all that gap, okay? It's not the space occupied by the molecule themselves. That means that molecules, because they don't occupy any space, so you can squeeze those that 20 liters of gas to bring it to zero, because that 20 liters is all empty space. So you can force the gas molecules by applying pressure and by cooling them to come closer and closer, and when they come closest, they will have no space left. That means they lose all their volume, okay? So this is what is said in the sixth postulate of kinetic theory of gases. I want you to copy all this also, because they are important, because this entire chapter is based on whatever is said in this theory called kinetic theory of gases. So you have to remember all of these postulates. Now the last postulate. You know, gas molecules are moving randomly, and when anything moves, it acquires a form of mechanical energy called kinetic energy. Whenever an object is moving, it possesses a certain amount of energy called kinetic energy. When you are not moving, you will not have that form of energy called kinetic energy. Your kinetic energy will be zero. But the moment you start moving, you will acquire that energy called kinetic energy. So kinetic energy is energy acquired by objects due to their motion. So gas molecules are randomly moving, and that means all those gas molecules have kinetic energy. But do you think all the gas molecules have equal kinetic energy? No. They will not have same kinetic energy. You know why? Because kinetic energy depends on the speed or the velocity of gas molecules. Faster you move, more kinetic energy you will have. And as you know that gas molecules are not moving with the same speed, some are moving slow, some are moving fast. So those which are moving slow will have low kinetic energy. Some are moving faster will have higher kinetic energy, and someone which is moving very, very fast will have highest kinetic energy. So that way gas molecules, because they are moving with different speed, they will have different kinetic energy. Their kinetic energy won't be same. So then when gas molecules have different kinetic energy, then how to express the kinetic energy of gas molecules? If you say gas molecules have low kinetic energy, then it is wrong, because some gas molecules which are moving fast, they have higher kinetic energy. And if you say gas molecules have high kinetic energy, that is also wrong, because some molecules which are moving slow, they have low kinetic energy. So when you have different kinetic energy of gas molecules, because they are moving differently, how do you express the kinetic energy? We can express as an average. What you can do is you can add the kinetic energy of all these and then divide by the total number of molecules. That's how we get average. For example, how do you calculate the average of ages of three different friends? Let's say you have three friends and they have different ages. So different you have three friends and three different ages are there. Let's say someone is of 17 years, someone is of, let's say, 15 years, someone is of 16 years. How do you calculate the average age of these three students? You've got to add the ages of all the students and then divide it by whatever number of students are there. Let's say how many are there? 3 students are there, so you divide by 3. So that's how you can calculate the average. In the same manner, you can calculate the average kinetic energy of gas molecules, because their kinetic energy are not equal. So you can calculate the average by adding kinetic energy of all the gas molecules and dividing by the total number of molecules. That's why whenever we talk about the kinetic energy of gas molecules, we always use this term called average kinetic energy, because their kinetic energies are not equal. So the last postulate of kinetic theory of gases says that average kinetic energy of gas molecules is directly proportional to their absolute temperature. So presently you will not understand the meaning of absolute temperature, because we'll deal this with this term. You know what is temperature, but you don't know what is absolute temperature, because this will come later when we complete discussing the gas laws. So presently I just don't want to focus on this term called absolute, because it will not make any sense. So we'll only talk about temperature. That average kinetic energy of gas molecule is directly proportional to their temperature. What's the meaning of that? That means when the gas is at low temperature, let's say 10 degree, then gas molecules will have less kinetic energy. That means at low temperature, gas molecules are moving slowly on an average. That's why they have low kinetic energy, because kinetic energy is directly proportional to temperature. When temperature is high, kinetic energy is also high. Now when the temperature is low, when it's only 10, then the kinetic energy is also low, because they are directly proportional. That means molecules are moving slow. Only then they will have low kinetic energy. As you increase the temperature of this gas, that means by heating, you are increasing the temperature of this gas, let's say to 20 degree. Then what happens? When the temperature increases, because average kinetic energy is directly proportional to temperature, when temperature increases, their average kinetic energy also increases. That means gas molecule starts moving faster and faster. So as temperature increases, molecules starts moving faster and faster. So at low temperature, all the gas molecules are sluggishly moving, slowly moving. And when temperature increases, their kinetic energy also starts increasing. That means molecule starts moving faster and faster. So this is the last postulate of kinetic theory of gases. You are supposed to remember at least these 2 points. These 2 points are very, very important. The sixth one, which says that gas molecules themselves do not occupy any space. Whatever space gases occupy, whatever volume gases occupy, is all because of the wide gap between the molecule. And another, that the average kinetic energy is directly proportional to the absolute temperature. In fact, all the postulates are important, but these 2 are quite important, okay, for you, more important than the others.